Today we're going to look at a sample that contains 1.388 grams of carbon, 0.345 grams of hydrogen, and 1.850 grams of oxygen, and its molar mass is 62 grams. What is the empirical molecular formula? We're going to start by finding the empirical formula. So I'm going to take the grams of carbon, 1.388 grams of carbon, and I'm going to turn it into moles. So that gives me grams goes on the bottom because I don't want it. Moles goes on the top. I know 1 mole. There are 12.01 grams of carbon. Grams will cancel. Using my calculator, I get 0.11557 moles of carbon. So now I need to find out hydrogen, and I have 0.345 grams of hydrogen. I put it over 1. I don't want grams, so grams goes on the bottom. I want moles, so moles goes on top. I know in 1 mole there's 1.01 grams of hydrogen. I do my math, and I get 0.34158 moles of hydrogen. Then I'm going to take 1.850 grams of oxygen, put it over 1. I don't want grams of oxygen. Grams goes on the bottom. Moles goes on top. I know in 1 mole of oxygen there's 16.00 grams of oxygen. Grams of oxygen cancel, and I get 0.11562 moles of oxygen. At this point, I have everything in moles. I now need to divide by the smallest moles. So I'm going to divide by carbons, 0.11557, and that's going to give me 1 mole of carbon. I'm going to divide hydrogen by 0.11357, and I'm going to get 3 moles of hydrogen. And I'm going to divide oxygen by 11557, and I'm going to get 1 mole of oxygen. So to go next, I'm going to actually write my empirical formula from this. So I see that I take the 1 that was with the carbon, the 3 that was with the hydrogen, and the 1 that was with the oxygen. Remembering when I write empirical formula, I do not include the 1s. So I'm simply going to rewrite and have CH3O. Now, I'm not over with the problem. That's the empirical formula. But I also need to find the molecular formula. I need to remember that empirical formula and molecular formula are multiples of each other. So I need to find that multiple. In order to do that, I need to know the molar mass of the empirical formula. To do that, I simply add up the atomic masses. So I have 12.01 grams of carbon, plus 3 times 1.01 grams of hydrogen, plus 16 grams of oxygen. And I get a the molar mass to be 31.04 grams. Now that I know the molar mass of the empirical, I can compare it with the molar mass of the molecular. So I take the molar mass of the molecular formula, divide it by the molar mass of the empirical formula, plug in my numbers, and I have 62 grams for my molecular formula, while I have 31.04 grams for my empirical, and that's going to give me 2. So to actually find the molecular formula, I'm going to multiply the 2 by CH3O, which is the empirical formula, and I'm going to get a molecular formula of C2H6O2.